Okay, girls, this is on your third lesson on coordinate geometry of the circle, and it's equations of the form x squared plus y squared plus 2gx plus 2fy plus c is equal to 0. It's another way of writing the equation of a circle. It's also another way of describing this form. It's called the second, and you see it here, it's called the second degree equation, okay? So the formula goes by x squared plus y squared plus 2gx plus 2fy plus c is equal to 0. Obviously, you might have values for g, you might have values for y, you might have values for c. How we read the centre is minus g minus f, okay? And how we would read the radius is the root of g squared plus s squared minus 2. And again, it's in your formula and tables book, page 19, so you do not need to learn it off. So as I've pointed here, and I want you to take down all this slide here, remember, secondary equation represents a circle if the coefficient of x squared and y squared must be equal. So look at the coefficient here. They're equal, aren't they? 1 in front of it. The highest power is 2. Highest power is 2. Highest power is 2. Power of here is 1, power of here is 1, and there cannot be an xy term. So the only way you can actually use the second degree equation if all of those criteria are met, okay? So the coefficient of x squared and y squared must be equal. The highest power of x or y is 2, and there cannot be an xy term. So you can't have like 2gxy, something like that, okay? So find the centre and the radius length of the circle, right? So we have it in the form x squared plus y squared minus 4x minus 6y minus 12. So does it follow that criteria, right? It is very similar to this format. The coefficients of x and y are x squared and y squared are 1. Yes, it does. The highest power of x squared and the highest power of x and y is 2 here. And there cannot be an xy term. No, there isn't an xy term. This is just an x term, this is just a y term, and this is a constant. Okay, so let's set down. Let's write down x squared plus y squared plus 2gx plus 2fy plus c is equal to 0, and let's find g and f first of all. So underneath that, directly underneath that, I'd write out my equation that I'm given. Now, what can we say? Let's look at what we have here. So that corresponds with that corresponds with that. We could actually put down here that 2g is equal to minus 4, because the two x's will kind of cancel if you look at it like that. So we're comparing then. So we can have 2g is equal to minus 4. Okay, so that should be minus 4 there. Sorry, they have made a mistake. Yeah, I actually realised when I was going back over this, that should be minus 4. So it changes it here. For some reason, they have 4 there, right? So ignore that. When I was going back over it, I was trying to figure out how I could change it, but it wouldn't allow me to change it, okay? So, sorry, just go back over that. So that should say 2g is equal to minus 4, and then we have 2f is equal to minus 6. That's fine. So then we solve for g. So g is going to equal to minus 2, because that should be minus 4 there, so change that to minus 4 in your notes. And 2f is equal to minus 6, so f is equal to minus 3. Okay? Then the centre then is minus g minus f, which is going to be minus minus 2, which is 2, and minus minus 3, which is 3. And then how do we get the radius then, right? Let's put down our formula for the radius. Let's fill in what we have. So what is g? G was minus 2. Again, that should have been minus 2 here, right? So I'm actually going to change that if it allows me to change it. So that should be minus 2 squared. And f should be minus 3 squared. But obviously if you square... if you square a negative number, it becomes a positive, obviously, right? So we have minus 2 squared plus minus 3 squared minus minus 12, because we have c is equal to minus 12. Look, we're comparing. C is equal to minus 12. So that minus is there already. Remember, that's part of the equation. And then c is minus 12. So that will just come out. Then you can put that all into your calculator. Is the square root of 25, I'd say, which will give me 5. So for this particular circle, we can easily read that the centre, using this criteria, using these formulas here, that the centre is 2, 3, and the radius is 5. Okay? Now another example then, which is one that was taken out of the books, right? So a circle has centre 4 minus 2 and radius length 5. Find the equation of this circle in the form x plus y squared plus 2gx plus 2fy plus c is equal to 0. So the first thing I would do is, right, let's think about how I would set up this format, right? So you could kind of, I suppose, the easiest method, I think, they give you two methods here, but I think this is kind of the easiest method because you're used to this, right? So we can say this is center HK, okay, and this is R is equal to 5. So couldn't we put it into our second formula, which is x minus h all in brackets v squared plus y minus k all in brackets v squared is equal to r squared. And that would give me, just substitute in x minus 4, because that's h, and y minus 2, which become plus 2, is equal to r squared, multiplied out. Now all you're doing is you're expanding the brackets, okay? So doing your distributive method, this is x minus 4 times x minus 4. This is y plus 2 times y plus 2, multiply it out. Put it in this order then, right? So you have x squared minus 8x plus 16 plus y squared plus 4y plus 4 is equal to 25. Now it's not in that format yet. So let's bring everything over to the other side. Remember, for it to be in the second degree format, it has to have x squared plus y squared, now minus 8x, which is the coefficient of the x term, and then plus 4, and then minus 5. And you could even check your answer, because let's compare here. If we said 2g was equal to minus 8, we'd have g is equal to minus 4. Wouldn't we? And we said the centre is minus g, so that'd be 4. Yeah, that's correct. And say here we're comparing. If we said 2f is equal to 4, so f then is equal to 2, so minus f is equal to minus 2, and that would be correct. The second method then is, right, so let's take it as you're writing down the formula that we have, the second degree formula, or second degree equation formula, which is x squared plus y squared plus 2gx plus 2fy plus c is equal to 0. You know, as I said, that the centre in this format is minus g minus f. So minus g minus f is 4. So therefore, isn't g equal to minus 4 and isn't f equal to 2? Then we could put it into the formula then to work out the radius. So you're putting it in the radius form, g squared plus f squared minus c is equal to 5, okay? Now, how did we know that that was equal to 5? We're told up here, right? So it's like you're kind of simplifying, right? So you're squaring both sides, get rid of the square root. You're putting in what g is equal to, you're putting what f is equal to, that will give you c straight away. It's like algebra. So c is equal to minus 5, so therefore you have g, you have f, and you now have c, so you put it back into the formula. So it's another way of doing it, right? And it is kind of straightforward. It's probably a little bit more tedious than this method, but it still works out perfectly fine. So whatever way you understand better, stick with it, okay? Right, next point that I'm going to bring in when we're talking about this particular way of working out the equation of a circle is points that are inside, outside, or on the circle, okay? Okay, so if we look at this diagram first of all. So what we have is a circle here with centre O. We obviously know that the distance from here to here is the radius. So this is a point on the circle. And what we can say that the length OP is equal to the radius, isn't it? So P is on the circle. So if they ask you to check whether a point is on a circle, you get the distance from the centre to that point, and if it's equal to the radius, then it's on the circle. Look at this now. We have circle with centre O, we have point P, and we also know that the radius length is going from here to here. So if we were told in the question that the radius length was equal to 5 or something, and we got that the distance from O to P was actually equal to 3, then isn't that less than the radius? So therefore the point is inside the circle. So if you're not given the diagram, if you got the length between OP and you found it to be less than the radius, then it's inside the circle, okay? The next one then, we have circle with centre O, and we know the radius length is obviously any point that is from the centre of the circle to the edge or outside of this, that's touching the centre to the edge of the circle is obviously the radius. But if the length from O to P was greater than the radius, then we can say that P is outside the circle, okay? So as I said here, just to summarize, points inside, outside, or on the circle, right? So another way of saying it, that if a point is inside the circle, then we can say that the x minus h all in brackets c squared plus y1 minus k all in brackets c squared is less than r squared, right? So the x and the y1, they would be your coordinates for the point, and your h and the k would be your centre. Remember, we also always said that h and k is the centre. I would like you to take this down as well as the other slide on that previous page, okay? So if a point is outside the circle, then x1 minus h all in brackets squared plus y1 minus k all in brackets squared would be greater than r squared, okay? And that also makes sense, doesn't it? So inside the circle would be less than the radius squared, greater than radius squared is outside the circle. And obviously then, if the point is on the circle, then x1 minus h all in brackets squared plus y1 minus k all in brackets squared is equal to r squared. Okay, so that's another way of showing or proving whether a point is inside, outside, or on the circle. So investigate firstly, right? Now this is if you're using equations, but let's just go back to these particular graph style. It's another way of working it out, right? If you had the center, if you had a point, you could work out the distance. And obviously once you're given the radius, you can compare it that way. But if we're doing it as regards the equation of a circle, this would be the way to work it out. So this question here, investigate if the points 7 minus 5 and 8 minus 6 are outside, inside, or on the following circles. Okay, so let's take the equation, which is x minus 4 all in brackets squared plus y plus 1 all in brackets squared is equal to 25. So remember how we would read the centre be x minus h plus y minus k and r squared is equal to 25. But at the moment, what we're going to figure out is that if we take this as x1, this is y1, plug it into this formula. If it's less than r squared, because that is r squared. If it's less than r squared, it's inside the circle. If it's greater than r squared, it's outside the circle. Or if it's equal to 25, which is r squared, it's on the circle. So the point 7 minus 5. So what we do is plug it in. So remember, we're taking this as x1, y1, or you can just take it as x and y. I know they have x1, y1 up here, just show that that's the x coordinate of one point and the y coordinate. Plug it in. Right, so let's see what we get. So we get 9 plus 16 is equal to 25. So 25 is equal to 25. So what can we confirm? That 7 minus 5 is on the circle. Let's take the other set of coordinates, which is x minus 6. And let's figure out whether that point lies outside, inside, or on the following circle. So we will take 8 minus 6. We'll call that x. We'll call that y. We'll plug it into our equation. So I'd always mark xy, right? And let's see what we get here. So we get 16 plus 25. So we get 41 on the left-hand side. That's not equal to 25. It's actually greater than 25. So what can we confirm? That it's greater than r squared, so it lies outside the circle. So like a point, so we can see from those 2 points then, if we were to look back at the diagram, that this could be the first equation, and this could be the last equation then, or where the point lies. So one is on the circle and one is outside the circle. Okay, so note, as it says here, right, if our equation of the circle is in a second degree form, which is x squared plus y squared plus 2gx plus 2fy plus c is equal to 0. If a point is inside the circle, so this is also important to take down, that we've got x1 squared plus y1 squared, which is basically just taking the x and y coordinates. So maybe 7 and minus 5 and 8 or minus 6. And if that's less than 0, if it's inside the circle. If the point is outside the circle, then x squared plus x1 squared plus y1 squared plus 2g times x1 plus 2f times y1 plus c is greater than 0. It's outside the circle. And then finally, if a point is on the circle when it's in that format, then x1 squared plus y1 squared plus 2g times x1 plus 2f times y1 plus c is equal to 0. Okay, so also important to take down those notes on this slide. Okay, let's look at this example here. So if the coordinates of a point satisfy the equation of a circle, then that point is on the circle, right? So as it says here, it's like, do you know when you have to show whether a point is on a line or a point is on the equation? You'd sub it in and it would satisfy the equation. The left-hand side would equal to right-hand side. So as this is here, if the coordinates of a point satisfy the equation, then the point is on the circle. So investigate if the point P 4, 1 is inside the circle x squared plus y squared minus 6x plus 4y plus 4 is equal to 0. So the first thing I would do is, how do I work out whether it's on the circle? Is I would maybe work out the centre, work out the radius length. Okay, so as they do here, and you can do it this way as well. Centre of the circle is 3 minus 2. How did I get that? By putting x squared plus y squared plus 2gx plus 2fy plus c is equal to 0, right? So centre is 3 minus 2. And I just read that from, putting it underneath and comparing. The radius length, remember, is f squared plus g squared minus c, okay? So we'll put that all in here. So what c is equal to 4 here, plug it in, and we get square root of 9, which is 3. So then the distance from the centre to this point here should be equal to the radius, okay? So if you put that in, you have the square root of 4 minus 3 all in brackets squared plus 1 plus 2 all in brackets squared. Now remember, I'd mark that x1, y1, x2, y2. I get that equal to be the square root of 10. So isn't the radius less than the distance from these 2 points? So since this distance of square root of 10 is greater than the radius, we can say that P41 is outside the circle. Okay, so as I said, that's one way of doing it, and it does make sense. Sorry, now I don't know why that's gone so... sugar, don't need that. Okay, so sorry, I don't know why that's actually shaken all of a sudden, the light, which is very annoying. So obviously, as I said, this is one way of working out or investigating if a point is inside the circle or it's outside the circle or on the circle, right? So remember I said to you at the start that the distance from the centre to that point should be equal to the radius if it's on the circle. The distance from the centre to that point, if it's greater than the radius, then it's outside the circle, and if the distance from that point to the centre, if it's less than the radius, then it's inside the circle. That's one way of doing it, right? Working at the centre, working at the radius length, getting the distance from the centre to that point and comparing it with the radius. Another way of doing it, which I explained in the previous pages, let's investigate whether 4,1 is inside the circle, outside the circle, or on the circle. Just take these coordinates, substitute them into the equation of the circle, which is in second degree form. What I got here was that 1 is greater than 0, so we can confirm or say that the point 4,1, which is point P, is outside the circle. And that's what you got in the example here. Okay, so hopefully that makes sense, and I'll give you a few questions then to try on that.